Good everyone, it is your favorite tutor and today is your favorite tutor on physics. Okay, today we'll be talking about arrangement of cells. Arrangement of cells, that is the connection of battery in an electrical circuit. We have the series connection, we have the parallel connection. We are going to treat them one after the other. First we start with the series connection. Okay, series connection. Now, talking about series connection, it's just like the resistor. When cells are connected in series, the positive terminal of one is connected to the negative terminal of another. And one thing about that is that the current is increased and the electromotive force also what? Increase in the circuit. For instance, something like this. This is a cell, this is a cell, this is a cell, okay, another cell. Alright. Now, we have the positive terminal, negative terminal, positive terminal, negative terminal, positive terminal, negative terminal. We can see that this is a cell, the first battery, second battery, third battery. The negative terminal of this battery is connected to the what? Positive terminal of this one. Negative, positive, negative, just like that. Positive, negative, positive, negative. That's the arrangement. So this is a series arrangement of what? Cells. It's just like the way we arrange a battery in a TV remote. Okay, I have a TV remote right here. You can see the arrangement. Positive, negative, then the other battery right here. Positive, negative in what? Series connection. If we interchange this battery now, for instance, we have two positive up, two negative down. If the second battery will counter the first battery, therefore obstructing the flow of what? Charges, and the remote will not work. So for series connection, the battery must align to one another. Positive terminal must end up meeting what? In the negative terminal of the next battery for what? Series connection. And one thing about this series connection is that the electromotive force is increased, that is the voltage is increased, and the current also what? Increase. For example, if this cells, first of all, they are what? Identical. They are identical. So if this one is what? 2 volts, this will be also be what? 2 volts. This will be what? 2 volts. They must be identical, just as the cell from the battery. You can see the cell from the battery, they are what? Identical, the same. So also it is right here, it must be identical. So for this series connection, the total electromotive force right here, the total EMF, that the total voltage in the circuit, is going to be 2 plus 2 plus 2, which is equals to 6 volts. 6 volts. Another thing is that the internal resistance of the cell is also what? Increase. If, for example, we have internal resistance right here, let's say the internal resistance is 1, due to the cells are identical, so all of them will take an internal resistance that's 1 each. So therefore, the total internal resistance will be what? 1 plus 1 plus 1, which is equal to what? 3 ohms. The voltage increase, the internal resistance also what? Increase. Okay, let's make this thing look more unique. Something, let's say, all right, for the connection can also be like this. Let's say this is a bulb, an electrical bulb. All right, this bulb is connected to a what? A battery in series, just a normal battery in series, positive terminal, negative terminal. Now, it's connected in series. The bulb will do what? Light up. That's what? Normal brightness. normal brightness. But if we add up another battery, let's make the battery 2. If we add up another battery, positive, negative, positive, negative. So we have 2 cells. The brightness of the bulb will do what? Increase. So if we add another one again, positive, negative, the brightness will do what? Increase. You can see that voltage increase, current increase, and the brightness do what? Of the bulb increase. So that's for what? That's for what? Series connection. All right, let's talk about what? The parallel connection. Parallel connection. Now, for parallel connection, the positive terminal of all the cells are connected together at a junction, while the negative terminal of all the cells are connected at another junction. All right, something like this. Something like this. We have the cell positive, negative, positive, negative, positive, negative. Now, all the positive terminal of the cell, they are all connected together. While all the negative terminal of the cell, they are connected together. And these cells, they must be what? Identical. So it's right here is what? 2 volts. We have what? 2 volts. We have what? 2 volts. Now, one thing about parallel connection is that for this, the total electromotive force right here in this circuit, the total electromotive force, the total EMF is equals to what? 2 volts. That's for parallel connection. It looks as if the total electromotive force is the voltage of just a single cell for parallel connection. While for series connection, the total electromotive force is the sum of voltage of for each of the cell. While for parallel connection, the total electromotive force is just the voltage of a single cell. And one thing about parallel connection is that the internal resistance of the cell is largely reduced. For instance, we have internal resistance, arrow, arrow, arrow. Then we have 1, internal resistance 1. Now, for when resistors are connected in parallel, the total resistance is the inverse. We take the inverse. So let us look for the what? The internal resistance. That is 1 over 1 plus 1 over 1 plus 1 over what? 1. So therefore, the total internal resistance will be, we have the LCM 1 plus 1 plus 1. So this is therefore equals to 3 over what? 1. Therefore, the total internal resistance is what? 1 over what? 3 ohms. So the total internal resistance right here for this circuit is what? 1 over what? 3 ohms. You can see that right here, the total internal resistance is what? 3 ohms. While right here, the total internal resistance is 1 over what? 3 ohms. So therefore, the internal resistance for cells connected in parallel is largely reduced. So please take note of that. All right, let's use this bulb as an example for parallel, the same way we did for series. Okay. All right, let me just clean everything. Okay, this is a what? A light bulb, electrical bulb. It's being connected to a what? To a cell. We have the first cell, the battery. What do you think will happen? The bulb will do what? Light up. normal brightness. Then we add another cell again in parallel. Add another cell again. Parallel. What do you think will happen? Nothing changes. The brightness of the bulb remains the same as just of a single word cell. We add another one again. The same thing, the brightness remains the same. So therefore, the total electromotive force here is going to be the what? The voltage of just a single cell. It looks as if we are using a what? A single cell. But one thing is that the internal resistance of this cell is largely what? Reduced. Please take note of that. For total EMF for cell connected in series, we just add them together. Total internal resistance of cell in parallel is just the voltage of one of the cell. Voltage of a single cell. Thank you for that. Take note of it, please. All right, I have a question on the board. A beautiful question. This question is good. All right. It says 6 identical cells, each of electromotive force 2 volts, are connected in series. Okay. There's a mistake here. Are connected in series. Should be in series because these are the cells are connected in series shown below. Determine the effective electromotive force of the cells. Now, these are the cells. Now, these cells, they are identical. So if one is what 2 volts, this one will be 2 volts, 2 volts, 2 volts, 2 volts, 2 volts. And there are 6 in numbers. They are connected in what? In series. We have to look for the what? Effective electromotive force. To look for the effective electromotive force is the same as the total electromotive force of the circuit right here. That is of the cells. Okay. So remember, in series connection, the positive terminal of one is connected to the negative terminal of another. So we are going to check if this connection is correct. Okay, we have positive terminal, negative terminal again. So therefore, this is cancelled out. It's going to obstruct the flow of our charges. So positive terminal, negative terminal again, negative. So obstruct the flow of charges. They said there will be no flow of charges. Okay. We have positive terminal, positive terminal, negative terminal. So we have 2 cells that are working in the circuit. Just 2 cells. So the total EMF is going to be what? 2 plus 2, which is equals to what? 4 volts. So this is the answer to the question. Ladies and gentlemen, we have come to the end of this episode. Please subscribe to the channel. Feel free to share the video. And then I remain your favorite tutor. Thank you, and God bless you.